We want to solve the given equation, then determine if any of the solutions are extraneous. Extraneous solutions are solutions we get algebraically, but don't actually satisfy the equation, and therefore are not solutions. Looking at the equation, notice we have a rational exponent. Recall we can write expressions raised to rational exponents as radicals, and therefore we solve equations with rational exponents similar to how we solve radical equations. Remember, when we have powers raised to powers, we multiply the exponents. To begin, we need to isolate the variable expression raised to the power of 1/2. This indicates the first step is to add 2 to both sides of the equation. Simplifying, we now have the quantity 5x plus 10 raised to the power of 1/2 equals x plus 2. And now remember, if we have a to the power of 1, that's equal to a, as long as a doesn't equal 0. So now we need to think about what power we could raise both sides of the equation so that we would have the quantity 5x plus 10 raised to the first power. And because 1/2 times 2 is 1, we now need to square both sides of the equation. Notice on the left side, again, because we have powers raised to powers, we multiply the exponents. 1/2 times 2 is 1. The quantity 5x plus 10 to the first power is just the quantity 5x plus 10. On the right, there are no shortcuts. We need to square x plus 2, and therefore we have 2 factors of x plus 2. Multiplying on the right, we have x times x, which is x squared, and then plus x times 2, which is 2x, and then plus 2 times x, which is also 2x, giving us plus 4x. Notice now we have a quadratic equation, and therefore we'll set the left side equal to 0 and see if we can solve by factoring. This indicates we will now subtract 5x on both sides, as well as subtract 10 on both sides. Simplifying, we have 0 equals x squared. 4x minus 5x is minus x, or minus 1x, and 4 minus 10 gives us minus 6. And now see if we can solve by factoring. If the right side does factor, it will factor into 2 binomial factors. The factors of x squared are x and x, which go in the first positions. The second positions must be the factors of -6 that add to -1, which are -3 and positive 2, which indicates we have a factor of x minus 3 and a factor of x plus 2. The right side is equal to 0 when x minus 3 equals 0 or x plus 2 equals 0. Solving for x, we have x equals 3 or x equals -2. We now need to check to see if these values actually satisfy the original equation. If they do, they're solutions. If they don't, they're considered extraneous solutions and are not actual solutions. So let's start with x equals 3. When x equals 3, we have the quantity 5 times 3 plus 10 raised to the power of 1/2 minus 2 equals x, which is 3. Simplifying inside the parentheses, we have 15 plus 10, which is 25. We have 25 to the power of 1/2 minus 2 equals 3. Recall, 25 to the 1/2 power equals the square root of 25, which is 5, and 5 minus 2 equals 3 is correct. X equals 3 is a solution. And now we'll check x equals -2. When x equals -2, we have the quantity 5 times -2 plus 10 raised to the power of 1/2 minus 2 equals -2. Simplifying inside the parentheses, we have -10 plus 10, which is 0. 0 to the 1/2 is equal to 0. 0 minus 2 equals -2 is correct. Both values satisfy the equation, and therefore both values are solutions. We have no extraneous solutions. I hope you found this helpful.